Hi everyone, welcome to Red Badger and welcome to the first We Love Tech meetup. It's probably a good idea to introduce this new community that we're trying to build. You may know us from the React London community that we've been running for about 3.5 years, but that's about one technology and that's not really who we are. So we thought we would start a new one that is much broader and get many more topics in and meet more people interested in more things because we're interested in all kinds of things. And so these meetups will happen every once in a while and every one of them will have a theme. Tonight's theme is peer-to-peer web as the first one. And you can tweet at us at WeLoveTech with the hashtag WeLoveTech. We also, come on, move. We'll have Slido for questions after the talk. If you want to speak, there's an email address you can email, or you can suggest themes for the next ones. And obviously we're hiring, so you can have a look at our jobs page. And am I missing anything else? Nope, okay. And so tonight, our speaker is Paul Frazee. He describes himself as an unblockchain consultant, which I find quite funny. And he's working on the Beaker browser, which is one of the projects, the important projects around peer-to-peer web. And he came all the way from Texas to talk to us tonight. So please welcome Paul. Give him a round of applause.
Excellent, thank you. Can you all hear me okay? Mic good? Great. Really big thanks to Red Badger for having me out. They paid for my flight and my stay here, so it's entirely thanks to them that I can come. Hopefully I'll give a talk that makes it worth it. So yeah, I'm going to be talking about the peer-to-peer web today. My name is Paul Frazee. I work with Tara Vansel at a company called Bluelink Labs that we founded together. We work together on the Beaker browser, which is an experimental peer-to-peer web browser, and that's what I'll be talking about here today. So to introduce this properly, I'm going to give a sort of short history of the web. At its most basic, you could think of the web as being, a document publishing network, right? So I have a document that I want to publish on the web. I'll upload it to a server, and that server then has an address, and my document that has an address. I share that address with people. They can download it from the server. There you go. Nice document publishing network. This worked really well, obviously. People wanted to add more features. So they began to, for instance, you want to do Wikipedia, right? You want to change the page, or you want to do Twitter, you want to do status updates. So we began to put code and databases up into the server. This also worked really well, so we got the cloud. And so now we have the always on, always available, great server-based architecture. The downsides were that it cost a little bit of money to run servers, more than most people had lying around that they wanted to spend. And it also required a little bit of technical expertise, right? More than most people had. So we had these companies come along and say, hey, don't worry about the tech, don't worry about the ops or the money, come over, use our service, it's free, just have to look at some ads, right? The inevitable result of this is we began to sort of centralize on these services, like Facebook, Twitter, Reddit, all the Google properties, and that's how we got to where we are now. So why do we not like that? What's the problem with that situation? Well, on the web, servers basically run the show, right? Everything gets decided by them. They decide what the code is going to be. They decide what the data policies are going to be or who you can connect to. So you're getting sort of a shrink-wrapped, pre-packaged experience whenever you're using servers on the web, which sort of reduces the amount of choice you have, right? And that problem was exacerbated by the fact that these web services are silos. They're not federated with each other. If you want to talk to somebody on Facebook, you have to be on Facebook, right? So what we're seeing is a really big reduction of the amount of choice you have. That manifests in a couple of specific ways. As an end user, I'm not able to edit the software on a web application. I can't make a pull request to Facebook. They're not taking PRs. I don't have direct control of my data either. The policies about who it's given to, how it's monetized. I can't take my data from Facebook and very easily transport it over to Twitter, for instance, because I want to exert some choice. I don't have ownership over that data, and I also have no privacy. They're able to surveil pretty much everything that happens on their service. That's sort of their right. There's also a couple of technical downsides to this. One is that we have sort of a monoculture. of using servers to do everything. So even if I'm trying to do something which is fundamentally peer-to-peer, like move a file from one computer to another, even if I'm on the same Wi-Fi with the computer, more often than not, I'll use something like Dropbox or Google Drive because it's just more convenient. The sort of the peer-to-peer facilities of networking right now are just so anemic that it's just like, just use Dropbox, right? But that's crazy. We're using a third-party service for something that is not necessary. Sort of connected to that is that since we use servers for everything, you have to scale vertically, right? If you happen to be unfortunate enough to make an application that everybody uses, you have to make it capable of supporting every single client that comes on, which again increases that cost barrier that I was talking about before, right? And then of course it doesn't work really well if you can't connect to that server. And there's some inroads being made with offline first, things like Service Worker, but it's still a fundamental problem that you can't update the source of truth if you're offline. Now, one way you could look at this situation is it's like the web is kind of a little society, or kind of a big society, really. And there's two kinds of citizens on this web. You have the server citizen, and you have the client citizen. And these citizens have different sets of rights. As a server, you have the right to publish, the documents like I was showing before. You have the right to set the code that you run. You have the right to moderate the content that people publish on your server. But if you're a client, and that's most of us, you have relatively anemic rights. You're only able to browse around from one side or another, and you can filter, so you can run like an ad blocker. But you don't have the same kind of power that a server has, which is to publish and moderate. That's all where the sort of experience is driven. So how do we solve this problem? Well, as much as possible, I think the solution should be that we try to get away from this two-tiered citizenship and instead move to a model where there's just one citizen, and that's just the device, users' computers, right? And that one device has pretty much a unified set of rights. The right to publish, the right to browse around, of course, to do moderation on your own, and to choose the code, so that we as end users have a much more direct say in what our web communities are like, okay? So let's get away from this server-based system and instead into a system where our own computers can have a direct control over the web. So that's what we're exploring, basically, in the sort of the broadest stroke possible. That's what we're exploring with the Beaker browser. Now, at the outset, what we're trying is a peer-to-peer network that replaces or sort of acts as a drop-in replacement for HTTP. So you're able to distribute sites on a peer-to-peer network, which means that any device on the network is able to create and publish a website. So you can do this with a mobile phone. You can do this with this laptop here. You can use a cloud server if you want. And you can make as many websites as you want. It's incredibly cheap to do so. You can just allocate these new websites. And then it has a sort of a BitTorrent behavior on this peer-to-peer network, which is that when you visit a site, people will help host the site afterwards, right? So you'll seed the site, which means that you help contribute bandwidth, right? And that helps keep the cost of hosting really low. If I were to host a video off of this computer here and it went viral, then we would have tons of traffic coming down and it would be crippling. But since we have this bandwidth sharing built into it, the network is sort of altruistic. It helps me pay for that bandwidth, right? So it scales up automatically. So how does this thing work? Well, we're going back to that document publishing flow here, right? So we're not going to use the server this time. I want to publish this document. Instead, what I'm going to do is I'm going to create a key pair. And I'm going to hold on to the private key, or the secret key, on my own computer. And then I'm going to use that public key as the address. So that's how we create a new website. We just create a key pair, and that public key becomes the new URL. And I can hand that out to somebody. And then they can find me on the network and download the documents directly off of my computer. Okay? So, and there's that. So then they're going to have a copy of the file. And like I said before, there's bandwidth sharing, which is kind of nice. So if somebody else shows up, they have the public key, they want to get the file, they can ask the network, OK, who out there has it? And they'll get two answers, my computer as the original author and the other person that downloaded it. And they'll be able to download the file from both of us or either of us, whichever happens to be online. And that kind of system scales up and up, right? The more people get added in, the more hosts you have on the network. It's kind of like we're all one big distributed web server working together. And it could even keep working even if the original author goes offline, which which is, again, good because it helps keep the system available and low cost. So that's what you call the swarm. So the swarm you could kind of think of as meaning a distributed web server. It's also kind of like a CDN, is one way to look at it, a big peer-to-peer CDN. Now, internally, the DAT protocol uses sort of like a Git log on the inside. It's not Git, but it's the same idea. Every time you make a change, you write an entry to this log. And so you're going to point to the file using a content hash, and then you sign it in that entry. And so each time you make a change, add a new file or change a file, you'll add a new entry, and you'll sign it with the private key. And then when somebody downloads it, they'll receive that same log. They'll check that signature against the public key. Matches. Great. It's part of the log. And they can actually, if you're part of the swarm, you'll receive these updates. You kind of pull for them. So you receive them in relatively real time, which is very nice for staying abreast of changes to a website or publishing data that needs to update in real time. You can actually synchronize it and get the updates. And from the perspective of a program, you get an event saying, hey, new version, go ahead and download it. So I found that the best way to demonstrate this stuff is actually just to get straight into the browser itself. So this is the pre-release version of Beaker 08. It looks like most web browsers. The goal has actually been to change as little as possible about the browsing experience. We want to be able to drop in these new technologies and then change nothing else. So this is like any other web browser. You can go to a website. Let's go to the Beaker homepage. And you can click around. This is all pretty standard stuff. You can bookmark things. But then if you look up on the top right here, there's a little badge that you don't normally see. So there's a peer-to-peer version of this website available. So why don't I go to the homepage first? And when I click on this badge, you're not going to notice that big of a change. So keep your eye on the top left where it says HTTPS, because that's all you're really going to notice changing. OK, we're loaded up. So this is the DAT peer-to-peer version of the Beaker browser homepage. Like I said, it's exactly like an HTTP version. That's our peer count. That's a bug. That's not quite right. But again, you got standard links, embedded images, things like that. In fact, the URLs look pretty familiar, right? If you look down at the bottom left, I don't know if everybody can see that. Why don't I just go ahead and click on it? So look at this URL here. This is almost exactly like the URL that you see in HTTPS. The only difference is that instead of HTTPS at the front, it's got DAT. But we're using DNS, just like you do on HTTPS. And you got a path at the end. So this should all be really familiar. The main difference is you have this peer count, which we could pretend, I suppose, 181 people. And that's a reflection of our swarm. All the different people that are either downloading updates or helping host the files that are already out there. And so I can click on this and actually get a little control where I can control how much I want to help keep the site online. So by default, you're only going to help what we call seed the files. That means rehost them. You're only going to do that for, at the moment, it's until you close the browser. But in the future, it'll probably be something like 5 minutes once we get the code written. But then you can go to this and say, you know what, I really like this site. I want to help out more. So why don't I take the slider and I'll say seed it for a day, give a day's worth of bandwidth, or a week, or a month, or you can even just go all the way up to forever. The advantage of doing that is that not only do you help keep the files online and get updates as they occur, but you also keep the files for offline browsing. So it basically stays cached on your computer so that even if you don't have a network connection, you can still access the website. It's a pretty handy additional feature as a result of that system. So let's see, what should I show next? One of the interesting sort of differences between DAT and HTTP is that the log that I was talking about earlier actually describes all the files that exist in the DAT. So we call these sites, we call them archives, actually, a DAT archive. And it's basically a bundle of files. And inside that bundle, you get a full site listing. So this is the source code of the DAT website that I was just looking at there. And a little bit of lag on this display. That's not the browser moving slowly, that's the display. Got to point that out. But this is pretty neat because for a couple of reasons, but for the moment, one of the neatest things is it's a great way to check out the source code of a website or an application. This is like view source on steroids, right? You can jump into the file listing and jump around into the JavaScript for a given page to find one that's not minified, see exactly how it works, right? And this interface that we're looking at here is built into the browser itself. In a lot of ways, it's quite a bit like looking at a GitHub repo. You can see the full file listing, browse around, and preview the things, open them up in a new tab, things like that. If I hop over to the network tab, I can see this history of connections. Now this is probably much more honest right here. That's one peer. We have a leak in our connections handling that doesn't seem to get them closed. So that, you know, maybe someday again, but that's someday that'll show the correct number of peers you got. And then you have some info like your basic manifest, what the title is. Eventually we're going to get some Git integration in here as well, but not quite yet. So, okay, we have static website browsing. That's nice, but it's not that unusual. Like I mentioned before, though, you can do hosting a website directly off of your laptop. So why don't we check that out? So if I jump into the menu here and hit Create New, I can actually have it create a new website for me. OK, so it's got a website for us, but a name for it rather, but let's change it to We Heart P2P site. Yeah, let's pick a favicon. Probably a heart seems right. And let's set a directory for it. Great. All right, now we're all set up. Created this directory with the files. So the flows I'm going to show here are sort of a development tool set to help you build out a peer-to-peer website or an application. We have actually succeeded in our goal. We've created a website. Here is the URL for it and the page that we have created. So this is some template stuff that gets put in there for you to help you get started with the website. You'll notice that URL is pretty ugly. It's a 64-character hex string up there. Probably won't memorize that. But that is a public key right there. 32 bytes, and it's an elliptic curve key. And it's kind of the equivalent of an IP address, right? Which typically we don't memorize those either. Instead, what you want to do is you use DNS to provide an indirection to it. But you don't have to do that. I could take this long URL and share it with somebody over chat or something like that, and they'd be able to pull this website directly off of my computer. So just like that, we've got a website created. So why don't we play around a little bit with the development tools. Let's see, I'm going to copy the path real quick and jump into Sublime. And let's drag that over. Let's see where we're here. Okay, there's our index.html. Now we have a little tool, which we call the workspace. And that's this path here. So we wanted to have a nice, simple way to be able to work on a website, see the changes that you made, and then when you're ready, you can publish it. So we have this idea of the dat site itself, and then a workspace that you can work inside of. And so that workspace has a little preview version. Here it is right there. Decided to allocate a name for us, Delightful Acoustics. So that's our workspace URL. I can't share that with anybody. That's just on my computer, right? This is just representing the folder that I'm working in. And to sort of demonstrate that, I make a few changes, refresh it, and there you go, right? Those exclamation points I added, right? So we're looking at like the dev version of the site. Does that all make sense? We can do a kind of a cool thing. We can turn on live reloading. So why don't we change this to something more appropriate? Right? Makes it a little easier to develop with. And then once we're ready to go, I'm back in that interface looking at the file listing, and you see there's a indication we've got an unpublished change. So if I click on that, it'll open up the workspace tab. We get a little diff there. And here is the active version of the site. So why don't we go ahead and publish this? And what we should see is Hello World should change to Hello London. Publishing done. Refresh the page, and there we go. Publish my new update to the website. And that live reloading I was doing on the workspace actually works on the DAT protocol as well. Because like I was talking about before, you're sitting there and you're pulling in the swarm for updates, right? So not only can we get live reloading on the local machine for something that you own, but you can actually do that over the network. So it's maybe not as impressive if I'm on my own machine, but if somebody else were developing this, I could get that same live reloading. All right. So we've got static website browsing. We've got static website publishing. Again, pretty cool, but we're still kind of in the Web 1.0 phase of things here, right? Websites are good, but we're used to having applications. So how do we possibly have the same kind of experience you get off of Twitter or Facebook or things like that, where you're having lots of smaller transactions between other people? Well, that's actually sort of the step 2 challenge of this whole thing. We've got a browser working, we've got the publishing, but making a complete application stack that makes it possible for these peer-to-peer websites to do everything that's on the web now is sort of the really big and interesting question about what maybe we can pull that off with this project. The really promising idea about that is that if we're able to use peer-to-peer networks entirely for applications, then we completely take away DevOps, because you're no longer having to set up servers. You can use a browser or your own device or a mobile phone. You can allocate a website, and you can just use the network to communicate with people, or use these websites to store user data. And it's going to take a lot of tooling, but what we've got so far, we've got at least one API, and that's the DAT Archive API, which basically allows us to interact programmatically with everything I've been showing you so far. So we're on my little Hello London page. We're in the dev tools for that. Why don't I make that a little bigger for everybody? Is that easy to see? We're good? So I just created an instance of a DAT Archive object for our current location. And you remember, well, why don't we read the index.html? And there's my Hello London, right? So that's using a sort of a file system API right there. That's pretty low down on the screen. Let me bring that up. So we have APIs for reading files. We have APIs for getting a directory listing. There's all the files inside this website. And we can do this with pretty much any DAT website. So let's do beaker.com equals new. There's a file listing for beakerbrowser.com. So that's pretty handy. It's handy not only for looking at and reading the content out of other websites, but it's also handy for making changes to your own. So why don't I turn on that live reloading I was talking about and jump back into the console. A is the archive that refers to the website we're on right now. So let's just make a destructive change. We're going to completely rewrite the website. And there it goes. So we got reading and writing programmatically on websites. You can build web applications this way, and you can build quite a few of them. We also have the ability, like I mentioned before, to listen for updates. So how far can you go with that? Well, that's actually an interesting question. I'll jump straight into maybe one of our most well-developed demos. This is called Fritter. It's a pretty blatant Twitter ripoff. But it is developed entirely on the DAT protocol. So all the activity here, all of the interface, everything that happens is entirely using this peer-to-peer network, which gets us into some interesting trade-offs. The basic behaviors work pretty well. There's Jim Pick tweeting about some things he's doing. I don't have image embeds by default, so let's see what he's. Some nice pictures of Vancouver he's showing there. There's Tara doing some, on Fritter it's called fretting. So she's fretting about working on Hashbase. And so, yeah, this is pretty much works the way you would expect. a Twitter clone to work. Got my bio, got my avatar, and all that. The way that it works, copy my profile URL there, and let's go ahead and look at it. So this architecture is one of many possibilities. I'll talk a little bit more about some of the experimental alternatives we're looking at right now. But the way we decided to do it with for Fritter was to simply write JSON files into websites. And so all the activity you saw on Fritter was actually just JSON. My profile, for instance, is profile.json on my personal DAT website. It's a little bit ugly there because it's not formatted, but there's my name, there's my bio right there. And then I got a list of people I'm following right here. So there's Tara Vansel, following her, and there's her URL, right? Which is actually pretty nice for discovering other people, right? I can follow somebody, and I can look at the list of people they're following, download their stuff, kind of expand out the network to discover more people. And then let's take a look over at the posts folder. Let's see, sure that my post that I just made ought to show up in here, but, well, you know, it's just JSON files, right? And this is an interesting one right here. So you got the text of the post that I made. You got the timestamp of when it was created right there. And then we have threading information saying, like, OK, yeah, this is a reply to somebody. If you look at the thread parent right there, you can see who I was replying to. Terribly long URL, but there it is. Thread root, right? And we can use that to reconstruct threaded conversations inside of this thing. And so the actual mechanics of publishing and synchronizing data is entirely occurring over the DAT protocol network, using just these peer-to-peer websites. And then on top of that, we use an indexer that is called WebDB that basically crawls around on these websites, finds the JSON that's interesting, and then sticks it into IndexedDB so that we can run really fast queries. So it's kind of like we're using a spider to do that. So I have a couple of other demos I could show, but I think I'll probably just head back to the slides, wherever those are. Yeah. OK. So let's talk a little bit. In the description of the talk, I said that I was going to tell a little bit about how you build applications in this system. So we'll just kind of briefly talk about some of those APIs. You can create new DAT archives using the APIs. It's as simple as calling that, and you get a new URL created for you right away. You got your file system APIs for reading and writing files. This should all look familiar to anybody that's used Node.js's APIs, except we use promises instead of callbacks. And then you can watch files for changes. I'm kind of in the process of renaming that API, so if you try it now, that won't work. But yeah, so you can watch for a directory, use a file pattern, and see when anything changes and get real-time updates. Really handy for whenever you're trying to build something like Fritter and you want to know if there are new posts out in the network, right? So this API is really good for publishing media. If you've got videos, audio, a website, something like that you want to publish, PDFs. Great for that. Great for basic file sharing. You can create a DAT website, stick some files in it, hand the URL to somebody. You'll transfer it right from one computer to another. And as in the case of Fritter, it's also not a bad way to do publishing user data, right, through JSON files. So that's where we're at right now. Coming up is some new work. For instance, the DATDB API. This is kind of like LevelDB, but put onto the DAT network. And this is actually new protocol work that's being worked on right now by Macintosh, who's the lead engineer on the DAT network. So it's key value stores. You can list the keys. You can watch for changes. It's just like LevelDB, except it's networked. And because of the way it's designed, you don't have to download the entire database to read keys out of this thing. It's almost like another DAT website, but a special sort of database website. And you can open the thing up and say, give me the key at foobar, and you'll just download only the information you need to get that one key. You can do a listing on it's actually a kind of a hierarchy, almost like a file system. So you can say, list all the entries inside the user's namespace, and you can get just a subset, which makes it very efficient over the network. And the scaling properties are pretty good. Macintosh was benchmarking it earlier. He was able to get, I think he got pretty much the entirety of Wikipedia into one of these things and was able to do a listing and random reads out of this thing very, very quickly. So the scaling property is looking pretty good. Another API that we're looking at adding into the entire system is, you remember that log I was talking about earlier that's inside of the data archive, where all the changes are signed and published out. We're talking about basically exposing that API directly. So it's an append-only log. It's almost like Apache Kafka, if you've ever used Kafka before. Decentralized peer-to-peer logging system. It's very, very handy for streams of data that changes over time, like video and audio, right? Also pretty handy for logging, and there's a use case with crypto contracts, which I don't have nearly enough time to talk about, but it's actually pretty interesting. Maybe someday that'll be another talk. Also looking at maybe setting up a replacement for WebRTC data channels, because we're not too happy with how they work, so maybe we can get data channels where you just give a public key and that finds the computer and gets you connected, and so you can do things like chat. Be real handy to have. And then finally, we're working on protocol updates. Again, this is what Macintosh is working on now, to make it possible so that those data archives I was talking about earlier, you could have multiple people collaborating on one of them and working together to make changes, so that, the way it works right now, only my computer is able to edit a data archive that I create. But in the future, we'll make it possible for more than one person to collaborate on a data archive. And we use CRDTs to merge those changes together without any conflicts, well, so to speak. So that is the talk itself, and then I think we have time for QA after a break, I think is the plan. So there we go. Thank you.
All right, please take your seats again. Let's go through the questions and give Paul a chance to explain. You can vote for the questions as well. If you like some on the list that are low down, you can upvote them. They will go to the top.
So is this on? We're good? Yeah. So before we get started, just kind of broadly speaking, how confused is everybody at this point? We have a basic kind of, got the high-level concepts? Cool. I mean, I can definitely retread any questions you have. But if people are confused about some of the basics of this stuff, which would not be hard to do, because I'm still learning how to communicate about all this, feel free to ask really basic questions, and I'd be happy to talk through it. And then also, if we don't have time in the QA, we can talk afterwards at the pub or wherever. So.
Cool. So the first one, the top one, what happens when there are no online peers?
You do not get the website. Yeah. Yeah. Yeah, I mean, at the end of the day, the altruistic system is helpful and cool, but it's not magical. There's no way that you can sort of say, push this thing to some peer who now has to keep this thing online, unless you have some kind of arrangement with them. But for the most part, if you're just relying on people to visit your device, you're going to need to keep your device online so that there's always one source that you know. To counter that problem, basically what we expect to do, and in fact, we've started a pinning service. And that's a service that acts like a peer for you, lives up in the cloud, keeps the thing online so that you don't have to keep your computer going. And that's how you make sure that you always have one peer. So, yeah.
How would you store something sensitive like customer data, which you wouldn't want to necessarily expose to everyone?
Yeah, it depends on what you're doing. There's different ways of managing private data. One of the inevitable futures is to get end-to-end encryption involved in the system, which should be actually pretty easy to do. You write a public key into your archive and say, if you want to encrypt something and send it to me, use this public key. That thing is signed, so you have a nice provenance of receiving that public key. And then somebody else can write a file or to their archive using that public key to get encryption done, or they can send it to you by some other means. But so encryption is one answer. The other answer is if you're trying to do something like a stockroom or like e-commerce, something like that, you're probably not going to want to use this technology. You're still going to want to have a service maintaining that, just because not only do you have to deal with sensitive records that maybe shouldn't be distributed out in the network, but you also have to deal with making canonical sort of transactional guarantees, like how many things are in the stock in the first place. That may end up changing. Maybe someday this technology will mature to the point where it's everything you can do on this. But for the moment, my advice would be, if you can't think of an obvious way for doing private data, then this isn't the right tech yet.
Cool, thanks. How does DNS for that protocol work?
That is a total cheat. So I'm going to steal this real quick so I can demonstrate something. The challenge that we have is that we need to not only have DNS, but we need to have it authenticated. Traditionally, in HTTPS, you would have an SSL certificate, which you would present in the handshake. We don't have SSL certificates for that yet. So, well, I downloaded it. To deal with that, bring that URL back. Let's try it on Beaker. Downloaded it there too. Okay, well you can see the URL still. So we basically decided, okay, we don't want to have unauthenticated DNS used because then it becomes very easy for somebody to give you a false record. We want to make sure that we're using secure information, authenticated information. So we have this record file that we put at .wellknown/dat. So whenever I go to a dat-based URL like this, we actually issue an HTTPS GET request to the .wellknown/dat address. And then that inside of it has the raw 64-character URL inside, as well as a TTL. So it's kind of like a little miniature DNS record in there. And that's what we use. And that's also coincidentally why we're able to know that there's a peer-to-peer version of a site available, because we can actually just check to see if that record is there, and if it is, we show that little badge. So like I said, it's a cheat. It wouldn't be the sort of thing that if I had total control, I would want it to work differently. But seeing as we need the solution now, that's what we decided to settle on. All make sense?
Do you plan to integrate with real DNS in some way? Like use?
It just sort of depends on if we can authenticate the data. And that may mean that we have to get involved with the PKI system at some point, the public key infrastructure, which is the certificate authorities. But that's obviously way into the future.
Grant is asking, at the end of the day, does this not still depend on some kind of central server to do the DNS or the DAT hash lookups? You sort of covered that.
Yeah, well, it's always sort of a trade-off game that you're playing. The most important, actually, if you really want to criticize how it's designed, you might point at the public pinning service that I mentioned earlier, right? The one peer that's in the cloud that keeps things online. You could say, isn't that just another web server? In a way, it is. But the major difference is that the signing keys for these websites live on your own personal device. And the URL is this hash. So there's absolutely no binding in the case of the infrastructure for hosting these things. There's no binding to any particular infrastructure, right? That public key URL gives you this sort of indirection. So even if all the files are hosted somewhere else, I maintain total control over it because the private key is in my control. The DNS thing, that's not so great. Maybe someday we'll get rid of that. But actually, DNS itself is extremely hard to decentralize. If you want to get away from, if you have lots of people collaborating on canonical information, you're either going to use a blockchain or you're going to use a service like DNS. So that was sort of a rambling answer, but there you have it.
Someone saying, awesome, why start with a browser?
We didn't, actually. Actually, I'd be interested to know this. Does anybody here know about the Secure Scuttlebutt project? Okay, cool. Yeah, it's like maybe a fourth, a third. So Secure Scuttlebutt is a project that I worked on prior to this that is a peer-to-peer, I guess I would describe it as a peer-to-peer social network, which shares a lot of the same kinds of design and technology that Beaker and DAT use. And so we started out by making a pretty good Twitter clone with end-to-end encrypted mail. And after that, one of the things that I ran into a lot was a difficulty making it a good ecosystem for other people to take advantage of that technology, right? We had this cool tech, and the point was to make it possible to make new applications that didn't rely on services. But as long as the tech was just sort of in one Electron app, which is how we delivered it to people, it was hard for other developers to be able to actually take advantage of the technology. So we had to come up with a way to make a potential ecosystem of applications build up around this peer-to-peer tech. So to do that, eventually it was like, well, there's really nothing better than having a web browser that works in a peer-to-peer fashion. And so that's how we ended up deciding, why don't we go ahead and make a browser.
How is the hash constant if the underlying archive is mutable?
It's not a content hash that we use as the address. It's a public key. That's a difference between, if you're familiar with IPFS, which we're actually in the process of integrating as well into Beaker, maybe 2 months. We you'll have read-only access to IPFS. IPFS is primarily designed to use content hashes as the URL. So let me ask this, show of hands, who here is familiar with content hashes? Okay, so most people, so the idea with the content hash, if you've ever used Git uses a content hash a lot. Famous one is called a SHA, so a SHA sum. It's a number that you can compute. So you take a file, you run it into a content hash, and you'll get out a number that's maybe 64 characters long. And if you reran that algorithm, that hash, you get the same number out. It's a really useful property because that means somebody can send me a file. Well, actually, first of all, somebody would send me the hash, and then somebody else could send me the file. And I could recompute the hash, and if the hash matches, I know it's the right file for that hash, okay? So it's like a name for the file that I can actually derive by looking at the content. And it's a neat property, but you can't change the file afterwards, or the hash changes, right? And so that's the way that IPFS is primarily designed, and we wanted to focus instead on the way that you normally think of websites, which is that they're dynamic. You usually expect to be able to change the content in the website. So instead we use public keys, which the public key can stay the same while the data underneath changes.
Would web crawlers still work in a conventional manner?
Yeah. The Fritter application that I was talking about earlier, it uses basically a web crawler to create the view that you see. And it's actually easier to do than normal because the DAT protocol gives you a listing of all the files in every website. And so rather than having to download an HTML file and look for links, instead we take an input DAT archive and we say, okay, are there any .json files under the posts directory? And if there is, go ahead and grab them and then parse them. So it's actually much easier to build a crawler on the DAT network. And so easy, in fact, that we have it in the browser. And it's sort of an interesting idea that maybe even we could build a browser directly in, or excuse me, a crawler directly into the browser and make that one of the standard APIs of the whole system, because aggregating data is pretty much always handy. So, yeah.
So then you have a search engine just built into Beaker.
Built in, yeah.
Cool. If the underlying data structure is a distributed log, how do you resolve information fast without traversing the entire log every time?
That is a great question from Macintosh, who's the main protocol engineer. He's been doing some really cool work with that, because that's actually a really good question. If you had to download the entire history every time you wanted to read information out of it, it would take forever. It wouldn't be efficient enough. And so you want to make it so that you just have to append a new entry to the end, but at the same time, you want to make it so that people can read randomly out of the entire thing. And how do you do that? And frankly, the data structure work he's done is a little out of my depth. He's using a tree structure, or a trie structure, TRIE, that is basically included in every entry. So it's almost like a little index is included in every update to the log. And as a result, he's able to really quickly find the right folder or the right entry in the history so that he can kind of skip around throughout the history and find precisely what he needs with, it's something like log n of the actual length of the thing. Like I said, it's a little bit out of my depth. You're gonna have to, I've been telling people just wait till he gives that tech talk. It's gonna be a really good one.
I should do a couple more and then break for drinks.
Yeah, sounds good.
Okay, cool. So the next one up is, how do user accounts work? How does Fritter only let you update your frits?
It's frets.
Frets. Makes more sense.
Let's see. Okay, so for the moment, the way it works is, I guess let me start by the second part of the question. How does Fritter only let you update your frets? The answer is that every DAT archive has a private key, right? And if you possess the private key, you're able to update the archive. That's pretty much the whole story. Beaker manages that so that the private key is never given to an application. The application has to ask for permission. So whenever it creates a website, implicitly it gets permission to write to the website afterwards. Or it can actually open up a little sort of modal dialog, almost like a file picker, and say, you know, give me a website to write to, and then you give it permission that way. So that's how you know that you have the right to write to it, is that you have the private key. Now, user profiles, we're sort of just using DAT sites as user profiles, since that's the thing you're writing to. So if I wanted to share my Fritter profile with somebody, I would take that 64-character long URL and give it to them, and I can use DNS to make it nicer, right? But I would give that to them, and that's basically the ID that I have inside the Fritter network. And even if we switch over, I mentioned the level DB style of interface, right, DAT-DB, right? That is still sort of like a website. So even if we end up switching over to using DAT-DB instead of JSON files, we'll still be just handing out these URLs. And so it's just kind of like a personal website, almost like a Web 1.0. Everybody's just got their own website.
So if you lose the private key, you're basically locked out.
You're in trouble
DAT.
if you lose the, yeah, don't do that.
Okay, last one. How does this differ from IPFS?
I sort of touched on that a moment ago. They're so close. The technologies sort of came up with like a little bit of overlap in the communities and different ideas about what the primary focus should be. And so now we all tend to talk to each other pretty frequently to see how closely we can get our work and make sure that we're all sort of moving in the same direction, because we're all after the same thing, which is to help create a web that's a little more open for everybody. IPFS primarily focuses on content hashes, which means that tends to be better for static information. Has some interesting value to that, such as if you get a link in IPFS, you kind of always get the same information every time, which is a cool guarantee. You can do interesting things with that. On the flip side, it's not so good for dynamic data. It's able to do it, but it's not as good. DAT's sort of the same way, but in the reverse. It's really great for dynamic data, for streaming that dynamic data, but if you want to have that guarantee of the static information, it can do that eventually, but it just doesn't do it as well as IPFS does, right? So each of them are sort of built for very similar design overall, but one big difference in their focus, and that's kind of how I would describe the two.
Okay, thank you. Thanks for your questions. If you have more, you can stay around and talk to Paul. Once again, we're hiring. Please tweet and post pictures on Instagram and everything similar. And thanks very much for coming, and watch out for the next one. I'm not sure whether do we know what the topic is for the next one? Maybe accessibility, but maybe not. Thank you, Paul, for speaking. It was amazing. And see you next time.
Thank you, everybody.